This video is on graphing quadratics. The graph of a quadratic function is a parabola and looks like this. Its equation in standard form is f of x is equal to ax squared plus bx plus c. The highest or lowest point on the graph is called the vertex. The x-coordinate of the vertex is the opposite of b divided by 2 times a. To find the y-coordinate of the vertex, we want to take our x value, plug it into the function, and that's going to give me y, or f of x. You'll notice that the graph of a quadratic function has what's called an axis of symmetry. This is a vertical line that goes through the vertex about which the parabola is symmetric. The x-intercepts are where the graph crosses the x-axis. This is the point where y is equal to 0. These are also referred to as the solutions of the related equation ax squared plus bx plus c equals 0. The y-intercept is where the graph crosses the y-axis. This is where x equals 0. And the y-intercept is the value of c in the function. If a is a positive number, that is, if the coefficient of x squared is positive, then the parabola opens upward and looks something like this, and the y-coordinate of my vertex is going to be a minimum value because that's the lowest point on the graph. If a is less than 0, that is, if my coefficient of x squared is a negative number, then my parabola is going to open downward, and the y-coordinate of my vertex is a maximum. It's going to be the highest value on the graph. The domain of every quadratic function is all real numbers. That means that x can be any value. And the range of the quadratic function is based on the y-coordinate of the vertex and the sign of a. So for example, here where a is positive, my range is going to be y is greater than, since it's going up, greater than or equal to the y-coordinate of my vertex. When a is negative and my parabola opens downward, my range is going to be y is less than or equal to the y-coordinate of my vertex. That's a whole lot of information. Let's see what it looks like when we actually graph a quadratic function. So we need to find each of the following for the function y equals negative 2x squared plus 4x plus 7. Let's start by finding the vertex. So I'm going to use x is equal to the opposite of b over 2 times a. b is 4, so the opposite of that is negative 4 over 2 times a is negative 2, or negative 4 divided by negative 4 is 1. So that means that the x-coordinate of my vertex is going to be 1. To find the y-coordinate of my vertex, I'm going to plug 1 into the function for x. So negative 2 times 1 squared plus 4 times 1 plus 7 gives me 1 squared is 1 times negative 2 is negative 2 plus 4 times 1 is 4 plus 7, that gives me 9. So my vertex is the point 1, 9. The equation of the axis of symmetry is x equals the x-coordinate of the vertex, which is 1. Notice that that's an equation with an equal sign. Don't say that the equation of the axis of symmetry is 1. That's just a number. It's the equation of a vertical line, which is x equals whatever the x of the vertex is. The x-intercepts, I'm going to come back to that in just a minute because that's a little more complicated. The y-intercept is the value of c, so my y-intercept is going to be the point 0, 7. Direction of opening, since a is equal to negative 2, my parabola, my quadratic function, is going to open downward. Because it opens downward, my vertex is going to be the highest point, so this graph is going to have a maximum value at y equals the y-coordinate of the vertex, which is 9. My domain is all real numbers, because the domain of every quadratic function. And my range is going to be y is less than or equal to, because it's opening downwards, the y-coordinate of my vertex, which is 9. Now let's graph this, and we'll come back to the x-intercepts in just a minute, but let's graph this by making a table of values. So I'd like a little XY table here. And I am going to take my value of my vertex and put that in the middle of the table. So that's the point 1, 9. And I know that that's going to be the point, well actually I could even go ahead right now. I'm going to go ahead and draw in my axis of symmetry. It's going to help me actually graph. I know that my parabola, my quadratic function, is going to be symmetric about that point. Let's choose a couple points, a couple x values that are smaller and a couple x values that are larger. Well, I know that when x is 0, that gives me my y-intercept, and I know that my y-intercept is 7, so that's going to be that point right here. I also know that it's symmetric about the axis of symmetry, so I know that there's going to be a corresponding point over here. So that's the point 2, 7. Now, if I plug in -1 into the original function, I'm not going to take the time to show you that right now, I get a y value of 1. And I know that, let's go ahead and do that, so -1, 1. Then I know that there's going to be another point over here at 3, 1 because it has to be symmetric. So let's go ahead and graph what we have so far. Now, remember we still haven't found our x-intercepts, and our x-intercepts are where it crosses the x-axis. And so far I haven't gotten there, and it doesn't look like it's going to be what I like to call a nice point, an integer value. So I'm going to have to choose a couple more points. I'm going to let x equal -2 and x equal 4. And when I plug those into my function, I get that y is equal to -9. So that's going to give me the point all the way down here and all the way down here. So my graph is going to continue like this. Okay, so that's good for a graph of the function. That looks really nice. But what I don't know is what my x-intercepts are, and those are going to be points right here. So notice I said that the x-intercepts are going to be when y is equal to 0. And you'll notice that somewhere between -9 and 1, and over here between 1 and -9, y is equal to 0. So my x-intercepts are not going to be nice points, but they're going to be values that are between, go back to here, I'm going to have an x-intercept between -2 and -1 and between 3 and 4. And those were those points here on the graph where the function crossed the x-axis between x equals -1 and x equals -2, and between x equals 3 and x equals 4. So in this video we took a look at how to graph a quadratic function, how to find the vertex, the equation of the axis of symmetry, the x and y intercepts, direction of opening, maximum minimum values, domain and range, and then how to graph.